Hello, Dr. Zoo. Hello, everybody. This is Khalid Al Mutwa, and I'm going to be talking tonight about our final project, which is the Can Crusher product. The team members are Khalid Al Mutwa and Sultan Al Aslani. Here's the project description. The project is about modeling and designing a can crusher. So, this is our final project, our final product as well. And that's the product that will be analyzed and assembled in our final project. We used Creo Parametric as a software to design our product by combining the parts all together. So we had 6 parts, and these parts are the base, slider block, holders, left arm, right arm, and finally the handle. Once we got all the parts designed, we started to assemble to get our final product, which is the can crusher. And we're talking about the original one here. The goal of our project, which is the most important thing in our project, is to make the assembly easier and less time to assemble as well. That's achieved and done by using the design for analysis, which helped us to improve our assembly product and come up with a modified model that has less parts. So we will be comparing the modified and the original one together, and we'll see the difference between both products in all aspects as well. Here's the project details, and we're going to be talking about the original product first. The original product consists of 6 parts. As you can see here, the first part is the base, the second one is the slider block, the third one is the holders, the fourth one the left arm, and the fifth one is the right arm, and the last part is the handle. So we will be talking about the base. The base is the most important part in our original assembly because it took us more time to assemble to design it actually than the others, and also the slider and a lot of parts will be attached and combined with the base as it's our main component. As you can see here, the slider block is the second part that will be attached in this area, and it will go up and down. Here is the left bar and the right bar. The only difference between the left bar and the right bar is the direction. As you can see here, I circled out the circle here and the pin, and also here to show you the difference between both parts. The holder, and here's the handle too. The holder, we had 2 holders in each direction and attached with the left and right arm just to help the slider block to go up and down, and this is the handle that will be attached in the center of our assembly so it can go up and down as well. That's the handle, and this is the holder as well. So now we're going to be talking about the modified product, which consists of 3 parts: the base, the slider block, the handle. I know we had the same names, but we made some modifications and some changes for the 3 parts here. So basically, we reduced the number of parts and we ended up with 3 parts for our modified product. There are some minor changes in the modified parts as well. So we will be talking about the base as the first thing. We start with the base. As we can see from the picture, we took out the bottom pins since we don't need it anymore because there are no more arm bars. And as what I'm saying is here, there are no pins here anymore because we don't need it in the modified assembly. So that's why we got rid of the arm bars, and also we got rid of the holders. And that's the change we did for the modified base. And here's the slider block, the modified slider block. We did a couple of changes in the slider block. We had 2 pins in both sides. We took off this pin, we got rid of it. So we had 2 pins in both sides in the original one, but in the modified one it has only 1 pin, and we took off the front pin because we don't need it in the modified assembly, and that made it easier and less time for assembling the modified product. We attached a small stick, as you can see here. We attached a small stick in the middle to make our modified assembly easier, so we just had to attach it with the handle without using the holders and the parts, which made our modified assembly easier and less time to assemble it. Here's the handle, which is the last part of the modified product. The modified handle has only one hole in the middle. This is the hole that we're talking about. So it can be attached with the stick of the slider block, unlike the original handle, which has two holes in both sides. So reduced holes is the major improvement of our modified handle. The original designed assembly. Here's the original product, the can crusher, and as you can see here, this is the assembly view of the original one, and as you can see, all the parts are combined together, and it shows the function of each part. And also we color the assembly and the parts to show you the difference, and to show you actually to give you show you different parts that has been modeled to ended up with this. And this is another view, which is the exploded view. And as we know, the exploded view is what you can drag the components away from the design assembly. Here's the modified assembly, which consists of less parts and took us less time to assemble it as well than the original one. And we colored it as well to show you each part clearly. As you can see, this is the slider block of the modified product, and this is the handle, and this is the base. We got rid of the pins as well here. Show you all the stuff that you want to know about the modified assembly and the difference between the modified and the original assembly. As I mentioned before, the modified assembly took us less time and cost to design it and implement it. Here's the exploded view for the modified assembly as well. Some of the parts were redesigned to fit the other parts. For the manufacturing plan for a part, we used the CNC, actually we used the Creo manufacturing for the NC assembly just to get our program. So we have selected one part from the original assembly that is suitable to run a CNC milling program on it, and this part is the slider block. We generated a manufacturing process plan for it. We used Creo manufacturing to get the desired CNC milling process. So the CNC codes will be showing up after once we are done with getting all the programs that we need. So once the process has been created, the toolpath will show how the process done. That's done by clicking on the manufacturing process tab and select the operations, then click on the tools to get you to the CL player. And here's our CNC program milling program, I'm sorry. And the K stands for the group members name letters. Actually, the K stands for Khalid and S stands for Sultan. And this is the CL player to show you what we've done for the CNC milling process. Now we're going to talk about the most important thing, which is the design for assembly. Design for assembly, first of all, the definition of design for assembly is a procedure that is the designing of parts and assembling the parts easy as well. Design for assembly helps to reduce the cost because of the easiness of the designed assembly with fewer parts. DFA improves the designed product by redesigning the parts and make it easier and faster to assemble. So this is the goal we are trying to reach or maintain. Design for assembly for a part. We redesigned some of the parts to fit our modified product, and that was done by using the DFA analysis. The part that has been redesigned is the slider block. We wanted to make some improvements with our modified product, so that's why we chose to redesign the slider block to look like what it's in the picture. And also we redesigned some other parts. In our modified product, we reduced the number of the parts to 3 instead of 6, as mentioned before. That resulted in changing some of the other parts, such as the base and the handle. Improvements made to all the modified parts to make it easier to assemble and in a short period of time. Here's the summary, which is the last part of our presentation. The product that has been assembled and designed as the can crusher. Improvements were made by using the DFA analysis, that is the main goal of our final project. And also the CNC milling process has been done to the slider block to generate a manufacturing process plan for it. The original product was compared to the modified product in all aspects, such as the number of parts, the type of parts, the complexity, and so on. Creo Parametric was the software we used to assemble both products. The original product has 6 parts and the modified product has 3 parts. The modified product was explained in detail on how we can come up with an easier product than the original one and analyze based on DFA analysis. And this is the final topic of our presentation, which is the summary. And thank you for watching us, and that's it.